So it's density in 3D notes. Like we just said, density equals mass over volume. And then you have the same density breaks my heart. D equals a broken heart. Yeah. Alright. There's nothing to this but to apply it. Let's practice. A block of gold has a mass of 9,660 kilograms and has a volume of 0.5 cubic meters. What is the density of the gold? So start out with the formula D equals M over V. This one we're looking for density, so D is my variable. M is 9,660 kgs over my volume, which was 0.5 cubic meters. Let me zoom in a little bit. And then we just need to do that math on this first one. Thank you, sir. 19,320. And this is kgs per meters to the third power. The unit part at the end don't matter. I just like to show y'all how it looks. See you online. So that's just regular density. If you get a problem, they ask you to solve for density, do that. If they give you mass and your volume. Number 2 is more like a situation you might see from us though. It says each side of a cube measures 3.9 centimeters. If the mass is 95.8, find the density of the cube. Round to the nearest hundreds if necessary. So on this one, they want to find density again. Density equals mass over volume. My mass is what, Faith? 95 point. What's my volume, Faith? No, ma'am. Thank you. We need to find volume. They said one side of a cube was 3.9. So obviously, my shape I'm dealing with is a cube. I need to find the volume of that cube. My little cube here was 3.9. Let's do some volume formulas. Cube is a prism, so volume equals capital B times H. Since it's a cube, what capital B turn into? It could be, but nah. More specifically, it's S squared. L times W won't be wrong, but the most specific answer for a cube is S squared. So then it's 3.9 times 3.9, that's S squared, times the height, which would be 3.9 as well. Volume of your cube. Marno, what's the volume of the cube? Thank you, as long as you know. Might want to warn him about that again. Say it, man. 32. No, it didn't tell. Oh, no, we don't round that. We round a final answer. This is centimeters cubed. Alright, then from there, now that we got a volume, we can plug in. So D equals our mass, which was 95.8, over our volume, which is 59.319 centimeters cubed. This was grams. Density equals what? to the nearest hundredths. 1.61 grams per centimeters cubed. My hand ain't in the way, is it? Sliding on. Number 3, the density of seawater is about 0.001027 kilograms per centimeters cubed. A tropical fish tank measures 50.8 centimeters by 30.5 centimeters by 30.5 centimeters. What is the mass of the seawater in the tank? Round your answer to the nearest hundredths if necessary. So they want to know the mass on this problem. Set up density equals mass over volume. They want to know mass on solving for M. I need to make sure I got density and volume first. My density is the 0.001, whatever. What's my volume? Huh? No. You say what? Are you just making up numbers? You think that's all you would have to do? Let me ask you a question, bud. What shape is a fish tank normally? Rectangular prism. Let's go there. Volume equals capital B times H. So rectangular prism, capital B turns into what? Hurry up. No. They already gave me my 3 numbers. Be smart about this. 50.8 times 30.5 times 30.5. Volume equals what? Oh, never mind, I ain't gotta wait. You should see this in the calculator. So that's the volume of my fish tank. Now I'm good. Now I can find mass. Density itself was this long decimal, 0.001027. This was kgs per centimeters cubed. And then I'm looking for my mass, so equals M over my volume, which I have now, 47,256.7 centimeters cubed. This is my setup. How do I solve for M? Thank you, sir. Perfect. Times by volume on each side. Times it by it on this side to cancel it out. On this side, I'm times it by my volume too. And then I get what my mass equals. To the nearest hundredths? 48 point what? Thank you. 48.53. This is kilograms. Because the centimeter square cube are going to cancel off. Don't ask me that until I explain everything. Alright, so that's the stuff on the front. Flipping to the back. Kind of throwing it over to you, but I will help you with setup first though. Number 4 and 5, you definitely should be able to do it on your own. Number 6, try. I will come back for the assist on number 6 though. 4 and 5, I'm not doing those for you, so if you don't do those, you won't have those in your notes. Yes, you should be able to do them on your own. Number 4 though, I will help you start it out. It says Christina is a toy designer. Because of her manufacturing costs, she needs to consider the amount of material needed to make toys she designs. She has designed a group of solid plastic toys with the given shapes and dimensions. Determine which toy has the highest density. So down here they give you the shape of each toy, the dimension, and they give you mass. To be able to find density, you need mass and volume. Well, luckily they gave you the dimensions of each figure so you can find volume. So what you want to do, you want to split this so you can, this is what most of my kids use. I'm going to help y'all with setup. They'll start out with a cylinder out here, split, do the cube next, split, then they'll do that sphere, and they'll split, then they'll do that rectangular prism last. My kids usually find the volume of each one, and then after that use that volume and then put it in the formula, do density equals mass over volume, and solve for the density. It's really not that hard. You got to find volume first for each one though. So, but you should know how to find volume of all these shapes now because we're at the end of our unit. I've taught you how to find volume of each one of these. You need to do it for yourself. Find the volume first, use that volume with the mass, find density. Easy work. On the problems, round to, for these, if necessary, round to the nearest thousands.